Hey guys, so here are the notes for 4.5. We are once again going to solve quadratics, but this time we're going to do it by taking the square root on both sides, or solving quadratics using square roots. Okay, now before we actually get into that, we need to review our perfect squares, because we will need to know that information in order to simplify when we are solving. So if you want to, go ahead and pause this video and list the perfect squares from 1 to 250. Okay, let's see what you got here. So our list will start actually at 1. So don't forget that 1 is also a perfect square here. There we go. So we have 1, and then think about what's 2 times 2? That gives us 4. What's 3 times 3? That gives us 9. 4 times 4, and hopefully you kind of get it. So we get 16, and then we get 25, and then we get 6 squared. 36. 7 squared is 49. 8 is 64. And then I'm just going to go ahead and keep going on here. 81, 100, 21, 144. Those you should kind of already have memorized. And then we kind of get to the others. So 13 squared is 169. 14 squared is 196, and 15 squared is 225. Okay. So these are probably what you should know. Basically, when you think about your perfect squares, you have two ways. You can memorize this list, that's fine. Or you can basically just think, okay, what is 2 squared? That's going to give you 4, and 4 is the perfect square. Same thing, like if you're thinking, well, what's 11 squared? That's 121. That's a perfect square. And you can also go into your calculator. I'm going to use the graphing calculator here, but if you have a scientific, you can do the same thing. And all you need to do is do second, and then the x squared, and then put in whatever number you need to. So like if we put 81, and I get 9. So if I get a nice number when I take the square root, that means it's a perfect square. But if I put in something and I get a decimal, then that's not a perfect square, okay? So that's another way to determine what is and is not a perfect square. So now we're going to use that information just to do some simplifying, because we'll use this when we actually solve. So let's look at part B. We're going to simplify the following radicals. Let's look at number 1. We have square root of 9. Now the very first thing you need to ask yourself, is this number a perfect square? So is 9 a perfect square? Yes, it is, because we can see that we have it on our list here, okay? So we just take the square root of 9, and if you don't remember that, you can plug it into your calculator. And when we do, we just get 3, and that's our answer. That's it. Okay, go ahead and do number 2 for me. Okay, let's see what you got. So we have the square root of 169. So once again, we have to ask yourself, is this a perfect square? Well, if we look at our list, yes, it is. And you can plug it into your calculator as well. So when we take the square root of 169, we should get 13. Okay, let's look at number 3. We have 27. Is 27 a perfect square? Well, if we look at our list, oh, it is not, because I don't see a 27 in our list. Okay, so when we don't have a perfect square, and let's say you don't have the list, right? So you can also just plug it into your calculator to see if it is. And notice we get a decimal. So we definitely know this is not a perfect square. Now, we are not going to leave our answer in decimal form. We have to leave in what we call simplest radical form. So our next thing is we need to figure out what is the largest perfect square that goes into 27. Now to do this, we are going to start where we can't do anything more. So anything that is bigger than 27, it can't go into. So like 36, 49, 64, if we try those, we get basically a fraction or a small decimal. So we are going to try all numbers below 27 for perfect squares and see if they work. So like 25, if you do 27 divided by 25, does 25 go into 27 evenly? No, we get a decimal, so that doesn't work. Okay, now let's try 16. So if you do 27 divided by 16, does that go into it evenly? That doesn't also, because we also get a decimal. So that's what you need to do when you're seeing if a perfect square goes into the number. Okay, what about 9? 27 divided by 9. Yes, that gives us 3. So now what we're going to do is we're going to do these branches. I have to include the perfect square, which is 9, and then I multiply it by the square root of 3. Now all of this is still underneath the square root because the 27 is. So 9 is our perfect square, and I take the square root of it, so I get 3. Now the other 3 that's underneath the square root, that is not a perfect square, and there's no number other than 1 that goes into it, so I just leave it inside that square root. Now make sure when you take the square root of a perfect square, just take it once, and it comes outside the radical, so it's no longer in there. So this is our final answer. Okay, go ahead and pause the video and try number 4 for me. Okay, let's see what you got here. So we have 80 here. I'm going to erase some of this stuff. There we go, the underline. There we go. Okay. So with 80, let's figure out, is that a perfect square? Well, we look at our list, we don't see 80. We see 81, but not 80. Okay, so now let's see what is the largest perfect square that goes into it. So I kind of like to draw a line because I know anything to the right of it that's too large, it won't go into 80 because we get a fraction or a small decimal. Anything below it we can. So what about 64? Can that go into 80 evenly? No. What about 49? No. 36? No. 25? No. What about 16? Yes. So that is the largest one that can go into 80. So make sure you always pick the largest. So we do 16, and we know 16 times 5 gives us 80. So we take the square root of 16, that gives us 4. Notice I take the square root once, and it's outside of the radical, and then I just leave the square root of 5 because I can't simplify it anymore. Okay, let's look at number 5. Now we're dealing with division here. So we have the square root of 4 divided by 9. Now when we have something like this, we're going to go ahead and kind of just take it apart. Meaning I'm going to have square root of 4 over square root of 9. Just so then I can think about the numerator and denominator. So 4, is that a perfect square? Yes. So when we take the square root of 4, it gives us 2. What about 9? That is a perfect square. So we take that, and that gives us 3. Notice that I only take the square root once of each number, and it's outside the radical. So our final answer here is 2/3. Okay, let's look at 6. So I have square root of 3 over square root of 16. Is 3 a perfect square? No. But is there a perfect square that goes into it other than 1? No, not really. So we actually leave that as square root of 3. We can't simplify that anymore. What about 16? Yes, that is a perfect square. And what's the square root of 16? It's going to be 4. So remember, just take the square root once and take it outside the radical. So our final answer here is square root of 3 over 4. Okay, make sure you watch the next video. It's now going to be over solving and using this information to simplify our answers.